Let's practice a few application word problems that apply our understanding of one-step equations. So we're going to be covering 4 different examples here where we're going to apply our understanding of solving one-step equations. We're going to make sure that we go ahead and set up an equation first that best represents the scenario that we're given, and then we're going to go ahead and show detailed and logical work using each of our properties to go ahead and get a solution, and then make sure, because it's an application word problem, we'll write a conclusive statement as well at the end. All right, so let's take a look at number 1. It says, after spending $294 shopping on Black Friday, Jocelyn now has $364 left. Let's go ahead and determine how much money Jocelyn had before she went shopping. So we don't know what she had before she went shopping, so let's go ahead and use a variable to represent that. I'm going to go ahead and use M to represent the amount of money she had before shopping. She went shopping, so she spent money, so that's going to be minus for the money. Now, how much was spent shopping? Well, it says over here that $294 was spent, so that must mean that we are subtracting $294. She's losing this money, but she's gaining some clothes, right? Or whatever else she might have bought. Now, it does say that Jocelyn has $364 left after shopping, so we can go ahead and say that $364 is what Jocelyn has after shopping. So this would be our one-step equation kind of setup here, right? We don't know how much Jocelyn had before shopping just yet, but we're going to subtract 294. That hopefully makes sense because when you shop, you spend money, and we are left with $364 after shopping. So let's go ahead and solve this equation now. So we see subtraction as our operation. What's the inverse? The inverse is going to be addition. So right under the minus, let's put a plus. Let's go ahead and add 294 to figure out what Jocelyn had before shopping. Let's go ahead and kind of go back in time and put that money back, right? Let's say Jocelyn returned everything. She gets the $294 back. We would figure out how much she had before shopping here. So what is a minus 294 and a plus 294? Well, those are opposites. So opposites always combine to make 0, right? So we have M, the amount of money that Jocelyn had before shopping, plus nothing here is equal to, and we have to figure out what's going to be on the other side of the equation here. So if we go ahead and add these two numbers together, we can go ahead and take this 364 and add this 294. If we go ahead and add those together, we're going to get an 8, and we're going to get a 15, carry the 1, and that's going to be 6. So we're really looking at $658. And we can use the identity property of addition because M plus 0 is really just the same thing as M. So we're going to go ahead and use that property and say M would be equal to 658. So what does this mean? This just means that Jocelyn had $658 before Black Friday shopping. All right, cool. Let's try another practice problem together. So in this problem, we see that after adding 4 2/3 cup of sugar to a bowl to make some cookies, Jonathan now has 6.5 cups of sugar in that bowl. Determine how much sugar was in the bowl before adding the additional sugar. So hopefully it makes sense here that we're going to use addition for the operation here. It does say specifically that 4 2/3 cups of sugar was added. So we're going to add 4 2/3 cups. And then what happened after adding the sugar, I think we know how much in total was in the bowl. It says Jonathan now has 6.5 cups of sugar. So that's going to be the total is going to be 6.5. And the question does say determine how much sugar was in the bowl before adding. So if we want to go ahead and say what was in the bowl before adding, we can maybe just use a variable for that. And let's maybe, I'll do B for before. You can use a different variable like X or maybe S for sugar if you want as well. So we don't know how much was in the bowl first, but then more was added, specifically 4 2/3 cups of sugar was added, and that results in 6.5 cups total of sugar. So let's go ahead and write this equation down. This is what was in the bowl before, plus 4 2/3, and that's going to be equal to a total of 6 1/2. So that's our one-step equation. The operation we see is addition, so the inverse is going to be subtraction. So let's go ahead and take away 4 2/3 from both sides of the equation. That's a subtraction property of equality. All right, so if we go ahead and subtract from both sides, we should be able to use the additive inverse property and see that if you add these opposites together or combine opposites, you always get 0. So we're going to get b plus 0, and this is going to be equal to, and let's see, we have to figure out what 6.5 minus 4 2/3 is going to be. So let's go ahead and figure this out on the side. So 6, let's figure out what these common denominators are going to be. Let's try to get the LCM to be 6. Let's do times 3 times 3. So 6.5 is the same thing as 6 and 3, 6. Let's go ahead and subtract 4 and what? Well, to get this 2/3 to have a 6, let's do times 2 times 2. So that's going to be 4 and 4, 6. All right, so we like to subtract these two fractions, but notice here how this 3 is smaller than this 4, so that's a little bit frustrating to deal with here. So let's borrow from this 6 here, let's make it a 5. All right, and then let's go ahead and add 6/6 onto the 3/6. If you add 6/6 onto here, you're going to get 9/6. And let's go ahead and subtract 4 and 4/6. Just leave this one alone. So we kind of just did some regrouping, right? We kind of borrowed 1 from the 6 and made it a 5. And we added on 6/6 onto the 3/6 to get 9/6. So we just kind of moved one whole over to the fraction part. So now 9 minus 4 works out really nicely. So 9 minus 4 is going to be 5. So we can say the whole numbers, 5 minus 4 is going to be 1. And then for the fractional part, 9/6 minus 4/6 is going to be 5/6. We have 1 and 5/6 here. Okay, so if you wanted to just go straight to improper fractions, you could change both of these to improper fractions and do it that way. That's also fine. So what's 6.5 cups of sugar? Take away the 4 2/3 cup of sugar. Well, we just found out that's going to be 1 and 5/6 cups of sugar. That's going to be before the sugar was added. Okay, so let's see, b plus 0 using what property? That's the identity property of addition. We can say b is equal to 1 and 5/6. Now what does that mean? It means there was 1 and 5/6 cups of sugar before adding more. All right, that's cool. That's it. All right, let's try another problem. Let's check out number 3. For number 3, we see here that Evie is going to be buying 8 of the same soccer ball, spending a total of $110.96. How much did one of these soccer balls cost? Okay, so what's the number of items here? Well, Evie's buying 8 of the same thing here, so 8 of these things. And what's the price of one of these? Well, we don't know the price of one soccer ball, so I'm going to go ahead and use P for the price. But if Evie's buying 8 of the same thing here, we would just multiply 8 times the number, or 8 times the price of each of these, right? Anytime you keep buying the same thing over again, you can just multiply the price of one by how many you're buying, and that should equal the total that you're spending. So $110.96 here. Okay, so let's go ahead and see here our equation here. What is 8 times p? 8 times p is simply 8p. It's just kind of simplifying that expression, and that's 110.96. So we basically are saying 8 soccer balls cost $110.96. All right, so we know the operation is multiplication here. So what's the inverse operation? The inverse is going to be division. So let's go ahead and divide, but specifically we're going to divide both sides by 8. That's a division property of equality when you divide both sides by the same number. Now, what is on the left side 8 over 8? Well, 8 divided by 8 is just equal to 1, so we can write 1p. So the coefficient for p is now just 1. So we have 1p, or the price of one soccer ball here, is going to be equal to. And now let's go ahead and divide the price of all 8 of them by 8, so we can get the price of just one soccer ball here. So let's take this 110.96. Let's go ahead and take that and then divide that by 8. So 8 goes into 11 one time. 1 times 8 is 8. 11 minus 8 is going to be 3. Let's bring down a 0. Now 8 goes into 30 3 times. 3 times 8 is 24. We have a remainder of 6. Let's bring this dot or this decimal straight up. And let's bring this 9 all the way down here. Now 8 times 8 is going to be 64. That's as close as we can get. Our remainder here is going to be 5. And if we bring down this 6 over here, we can see that we're going to have 56, and 8 times 7 is going to be 56. So we can see this goes in perfectly. So what's the price of one soccer ball? Well, the price of 8 divided by 8 is the price of just one. So it looks like it's going to be $13.87. And then using the identity property of multiplication, 1 times p is just p, we can say p is equal to $13.87. So in conclusion, we can say one soccer ball, that kind of looks like an I, maybe I'm going to say one, write it a little nicer. One soccer ball costs, we can just say cost here, $13.87. All right, cool. That's it. Let's try one more problem. In this one, we can see that L and 2 of her friends. So L and 2 of her friends. So how many people is that? That's going to be 3 people, okay, including L. And they want to split the bill evenly. So if they're splitting the bill, that means they're sharing it 3 ways. So we're going to put a division sign here. And it says they each ended up paying $83.94. So it looks like they maybe went out to a pretty pricey maybe restaurant here. So we can see this is going to be $83.94, and that's what each of them paid, right? So we're going to take the total bill. Maybe we'll put cost for the total cost. But if you split the total cost, split means division or divide, 3 ways, they each paid $83.94, then the total bill must have been quite a bit more than that, right? So how can we write this? We can write our equation as C over 3. C over 3 means C divided by 3, and that's equal to $83.94. Okay, so we can basically see here that the entire bill was split 3 ways, and this is how much each person paid here, right? So let's go ahead and see if we can use an inverse operation. So we see it's division. The inverse is multiplication. So let's go ahead and multiply both sides here. Now, if this is dividing by 3, the inverse is going to be multiplying by 3. So we can go ahead and use a hug if we want, because we have some decimals here. You can use dots on the left side and hugs on the right side, or you can just use hugs just to be safe here. All right, on the left side, let's go ahead and multiply these 2 fractions. So let's just go ahead and multiply the numerators and denominators. So 3 multiplied by c, that's going to be equal to 3c. And then on the bottom here, 1 times 3, that's going to be equal to 3. Now, what about on the right side of the equation here? Well, we have $83.94. That was the price for one person. But we're going to times it by 3 since they each paid that, right? So we take the $83.94 and we multiply that by 3. Let's see, 4 times 3 is 12, carry the 1. 3 times 9 is 27, plus 1 is 28, carry the 2. 3 times 3 is 9, plus 2 is 11, carry the 1. 3 times 8 is 24, plus the 1 is going to be 25. Now, we need 2 decimal places, so this looks like it's going to be $251.82. Now, on the left side, I think we can simplify this a bit. 3 over 3 is the same thing as 1. So you can see here that using the multiplicative inverse property, we get a 1 here. And 1 is equal to 251.82. Then if we go ahead and use the identity property of multiplication, 1 times c is just going to be c. So c is going to equal this 251.82. So what does that mean? It means the cost of the whole bill was $251.82. All right, so there you have 4 different practice problems. In each of these, one was addition, one was subtraction, one was multiplication, and one was division. And in all of these, we set up an equation. We then used an inverse operation on both sides of the equation. For the problems with addition and subtraction, we use the identity properties with those zeros. And then for the multiplication and division problems, we use the 1 for the identity property. At the very end, we went ahead and just summarized our answer because these are word problems and just wrote a quick sentence summarizing our results. So there you have your 4 different practice problems. If you feel like the video helped you understand this a little better, feel free to give the video a thumbs up. And as always, keep with the great work that you're already doing.